First of all, our original data comes from the government's public information platform. The data URL is below. It contains a total of 297 and 730 pieces of data, covering 15 variables. The target variable is 是否为参与方案院所。The time range of this data covers 2015 to 2023 and mainly records the fasting blood lipid examination status of diabetic patients. Among these variables, the nominal variable includes 是否为方案院所、年度、医师机构代码 and 医师机构名称。And continuous variables include 特约类别、执行空腹血脂检验人数、糖尿病病患且使用糖尿病用量之病人数、空腹血脂执行率、申报医师数、病患平均年龄 ，and 病患重大伤病比率、分母重大伤病人数、糖尿病照护方案参与医师数、县市别 and 乡镇别。Moreover, our data is complete and there are no missing values, which provides a good basis for analysis. And the purpose of our research is to determine 是否为方案院所 based on the fasting blood lipid implementation rate. We use 4 models for analysis. Is decision tree association rule, SVN and KNN. I will first introduce the decision tree part. In the decision tree section, we analyze following key points. The first is whether there is discretization. The first is whether there is discretization and the reason. The decision tree model is not discretized because the model itself can handle continuous variables well and automatically select the best cutting point. If discretized continuous variables may be lost, the important information hidden in it even increases the complexity of model calculation. Next is recording. I convert categorical variable like 是否为方案院所、年度医师机构代码 and 医师机构名称 to item dimensions to prevent the system from thinking that category variable have a sequential relationship. Next, I use the data. Cut the data into 80% for modeling, 20% for testing, and use the J48 algorithm because the decision tree model has good variable screen capabilities, and it can automatically identify the most important features of the target variable. And J48 using all variables helps retain potentially important information and avoid premature deletion of potentially relevant variable. Then we found that its test accuracy was 96.73%. And then here is my program code. Next is a comparison of 2 variable methods. First, Gini select variable. I found that it produced 3 prediction variables, predict 1 and predict 2, and we select the following 6 more important variables according to the importance of the variable. Then I found the best parameter of the model, CP equal 0.028, mean split equal 20, max depth equal 5, mean buckets equal 5, and use it to construct the model. I found that the depth of the tree equal 2, and its best training accuracy equal 0.9984, and its best test accuracy equal 0.9982. The second one is entropy to select variable. I found that it also produces three prediction variables: predict 1, and predict 2, and we select the following 6 most important variables according to the importance of the variables. Then I found the best parameters of the model. CP equal 0.0219, mean split equal 10, max depth equal 10, mean bucket equal 10, and use it to construct the model. I found that the depth of the tree equal 2, and its best training accuracy equal 0.9983. Its best test accuracy equal 0.9981. I compare the difference between 4 variables and partial variables. I found that the model with the highest training and testing accuracy rates were those using Gini to select variables, which were 0.9984 and 0.9982 respectively. Comparing the two models for selecting variables, we found that the accuracy of Gini's training and testing is higher than that of entropy. Based on the above results, I think the model prediction results constructed by Gini's variable selection method are the best, but it may encounter the following problems. Risk of the overfitting. Although the accuracy of training set is very high, the structure of the tree is too simple and may rely too much on certain features, lead to overfitting. It is recommended to further test and use cross-validation to evaluate the stability of the model. And the suggestion is to adjust parameters. The model may be too simple. We can try adjusting parameters such as max depth and mean split to enhance the complexity of the model and find more data structure and patterns. Next are rows 5x3 method. The first is all variable. If predict 2 then 4, assign to the left. If predict 2 then 4, assign to the right. And the second is Gini select variable. If 糖尿病照护方案参与医师数 less than 0.5, assign to the left. Next to is the explanatory diagram. The third is entropy select variable. If predict 2 then 4, assign to the left. If predict 2 equal 4, assign to the right. If 糖尿病照护方案参与医师数 less than 0.5, assign to the left. Next to is the explanatory diagram. Finally, we use Gini to select variables models for cross-validation. Since the data was too large, I selected the first 1,000 data for analysis and found the following variables with importance greater than 16. The results show that the accuracy rate equal 0.9983. Next, I will introduce the association rule. In this part, we analyze the following key points. This is the code I use for data preprocessing. There are no missing values in the data. By encoding the variables using one-hot encoding, convert the categorical variable into project scale, and also standardize and discretize them. Next are three resampling methods. The first is random oversampling. This method finally produced 122 rows. The following is the range of its three indicators: support, confidence, and lift. And the conclusion is at least 10% to 41% of the data conform to these rows. The probability that the condition and result are consistent is more than 95%, and the data has a high correlation. Use oversampling effectively expand the learning scope of the model in the case of a small number of categories. And here is my program code of oversampling. And here is the plot of oversampling. The second one is random undersampling. This method finally produced 118 rows. The following is the range of its three indicators: support, confidence, and lift. And the conclusion is at least 10% to 41% of the data conform to these rows. The probability that the condition and results are consistent is more than 95%, and the data has a high correlation. The rows obtained using undersampling are very predictive, which greatly improves the learning scope of the model. And here is my and here is my program of code of undersampling. And here is my program code of undersampling. And here is the plot of undersampling. The third type is smooth. This method finally produced 1,893 rows. The following is the range of its three indicators: support, confidence, and lift. And the conclusion is there are 10% to 100% of the data conform to these rows. The probability that the condition and results are consistent is 100%. However, the accuracy improvement using the smooth rows may not be very high. If we can filter out more rows with an improvement degree higher than 1, it may have more explanatory significance. And here is my program code of smooth, and here is my plot of smooth. Next is comparison of the effects of three types of resampling. We can see that the highest support result is undersampling, which means undersampling has the highest coverage. The highest confidence result is smooth, which means smooth had the highest confidence. And lift had the highest result is resampling, which means that oversampling has the highest improvement. Next is the most obviously rule of the three types of resampling. Oversampling's rules is if 病患平均年龄 equal 65 to 70, and 糖尿病照护方案参与医师数 equal 0.156 to 57.2. Prediction of target variable is yes. Here are the top 5 more powerful rules. And undersampling rules is if 病患平均年龄 equal 65 to 70, and 糖尿病照护方案参与医师数 equal 0.156 to 57.2. Prediction of target variable is yes. Here are the top 5 most powerful rules. The smooth rules if 糖尿病照护方案参与医师数 equal minus 0.175 and to 0.156, prediction of target variable is yes. Here are the top 5 most powerful rules. Next, I will introduce the SVM in this part. We analyzed the following key points. I didn't do the discretization because SVM can handle continuous variables. And I recording variables with one-hot encoding to let each category be an independent feature without introducing reasonable order or size relationship, and converts categorical data into numerical data to facilitate distance calculation. And I standardize the following variables. Then I built a model and found that its training accuracy equal 0.9996 and test accuracy equal 0.9994. The following is my code and result. Next, I will introduce the KNN in this part. We analyze the following case points. I didn't do the discretization because categorical variables are inherently discrete and can be handled directly by KNN. Similarity of categorical variable can be calculated by simple comparison without transformation. And it also can avoid unnecessary dimensionality and computational burden. And I recording variables with label encoder. The reason is label encoder is used to convert variables into numerical data, and each unique category is mapped to an integer to facilitate KNN algorithm perform calculations. And I standardize the following variables. Then I built the model and found that its training accuracy equal 0.9799 and test accuracy equal 0.9674. The following is my code and result. Finally, I use the training and testing accuracy to compare the following 3 methods. It can be seen that SVM has the highest accuracy in both training and testing. So I think SVM is the most suitable model for analyzing in this data. Thank you for listening.